Sketch the graph of the quadratic function f of x, which is equal to negative 2x squared plus 5x minus 8. Okay, so let's go ahead and take a look at first the values of a, b, and c in our problem. We know that a is equal to negative 2. We know that b is equal to 5. And we know the value of c is equal to negative 8. So the value of a is negative 2, which is less than 0. So we know that this graph is going to open down. Okay, so number 2, we want to figure out what the vertex is. So h is equal to negative b over 2a. So that's negative 5 over 2 times negative 2, which ends up being 5 over 4. And then for k, we know that's going to be f of 5 over 4 into the function. So we have negative 2 times 5 over 4 squared plus 5 times 5 over 4 minus 8. Okay, so what we end up getting is negative 2 over 1 times 25 over 16 plus 25 over 4 minus 8. So what we want to do is we're going to go ahead and maybe simplify, so we know that 2 goes into 16 8 times. So we have negative 25 over 8. Plus, we know that we want a common denominator of 8, so we can multiply this by 2 and 25 times 2, which is going to give us 50. Minus, if we want this to be 8, then 8 times 8 is going to give us 64. So if we take negative 25, add 50, which is 25, minus 64, is going to give us negative 39 over 8. So now we know what the vertex is. So the vertex is located at the following: 5/4 and negative 39 over 8. So what does the vertex tell us? Well, it tells us what the axis of symmetry is, and that's the x-coordinate here. So x is equal to 5/4 is the axis of symmetry. And then we know that negative 39 over 8 is, since it's opening down, this is the maximum at negative 39 over 8. So now what we want to do is we want to find the x-intercepts. And the x-intercepts is when we let f of x equal 0, or y is equal to 0. So we can look at the standard form, which is a times x minus h squared plus k, and we're going to set that equal to 0. So let's plug in the value of a. We know it's negative 2 times x minus, what is h? Well, h is 5/4, and then squared, and then it's plus k, which is minus 39 over 8, and we're going to set that equal to 0. Okay, so now we're going to solve for x. So we're going to add 39 over 8 to both sides. So we have 39 over 8. Okay, and then what we're going to do is then we're going to divide by negative 2. So if we divide by negative 2, that means that we're going to be multiplying by the reciprocal of negative 2, which is 1 over negative 2. So we're going to multiply this side by 1, negative 1/2, multiply this side by negative 1/2. So that means what's left here is x minus 5/4 squared, which is going to equal negative 39 over 16. Okay, so let's go ahead and continue here. So we need to take the square root of both sides. If we take the square root of both sides, we have x minus 5/4 squared, which is equal to plus or minus the square root of negative 39 over 16. Okay, so now we end up getting x minus 5/4, which is equal to plus or minus the square root of 39 divided by the square root of 16, which is 4, and that negative has to give us the imaginary number I. And so therefore the x-intercepts, if we add 5/4 to both sides, is going to be 5/4 plus or minus the square root of 39 over 4i. Okay, well, what does that tell us? Well, since it's an imaginary number, that means that the x-intercepts do not exist. Okay, so now we need to find the y-intercept. So we want to find the y-intercept by setting x equal to 0 in the function. So we know that our function again is negative 2x squared plus, let's see here, so we want to find the y-intercept. So it's at negative 2 times 0 squared plus 5 times 0 minus 8. So we know that gives us 0, that gives us 0, so we know that y is going to equal negative 8. So therefore the y-intercept is located at 0, negative 8. Okay, so let's go ahead and graph this. Okay, well, we know where our vertex is. Okay, so let's go ahead and rewrite that in terms of a decimal. So we have 5/4 and negative 39 over 8. Okay, so what does that look like as a decimal? So 5/4 is 1.25, and negative 39 divided by 8 is negative 4.875, or negative 4.88. So now let's go ahead and plot that vertex on our here. So we know that 5.4 is about 1.25, which is right here. And then we're going to go down to about 4.88, or negative 4.88. So we can say that our vertex is located right there. So there's our vertex at 1.25 and then 4.88. Okay, and then what else do we know? We know that the y-intercept is at 0, negative 8. Okay, so there's our y-intercept at 0 and then negative 8. And then what else do we know? Well, we know that we have a line of symmetry. Okay, and what does that line of symmetry look like? Well, we know that that line of symmetry goes through what value here? Oops. Okay, so we know it's going to go through this 5x equals 5/4. So there is our line of symmetry. Move that over just a tiny bit here. Okay, so we know that this x equals 5/4 is our line of symmetry. And so what's nice about that is that tells us how, it tells us what the distance is from this point here to here, which we know is 1.25. So we can go another direction of 1.25, which is going to give us 2.50. So at 2.50, which is located here, we're going to have another value here at 2.5 and then negative 8. And that allows us to then be able to create our parabola. So there is our parabola going in this direction, which is going downward. Okay, so therefore there is our parabola. So let's confirm this on Desmos. So we have negative 2x squared plus 5x minus 8. Okay, and then we also know that we have the axis of symmetry, which is x is equal to 5 divided by 4. So there is our axis of symmetry. So let's take a look at those values here. So we know that the vertex is located at 1.25, negative 4.875. We know we have a y-intercept at 0, negative 8. And then if we just move just a little bit to get to there, you can see that the other point is at 2.5, negative 8. So there is our parabola.